Hello viewers, in today's lecture we are going to start an important topic in mathematics that is called vector algebra. Now here in this lecture we are going to see a brief introduction of vectors. So viewers, we know that uh, quantities are of two kinds, right? So quantities are of two types. One is called the scalar quantities and others are called vector quantities. So what are scalar quantities? So scalar quantities are those quantities which have only magnitude, right? Which have only magnitude, and the quantities which have both magnitude as well as direction are called vector quantities, right? So in physical sciences or in mathematics we can say that quantities are of two types. One is called scalar quantities and others are vector quantities. Scalar quantities are those quantities which have only magnitude, and vector quantities are quantities which have both magnitude and direction. So let us take some examples here. So scalar, for example, we have mass. Mass is a scalar quantity, but force is a vector quantity because force has both magnitude as well as direction, while mass is explained through only magnitude. Okay, so these are the examples of scalar and vector quantities. Similarly, distance is also a scalar quantity, while displacement is a vector quantity, right? Now let us consider a straight line in three-dimensional space. Suppose this is a line L, and this line has direction like this, clear? Or this line may have the direction like this, clear? Now we know that a straight line in space extends in both the directions, and if we take a line segment of this line in a particular direction, then such a directed line segment is known as a vector, right? Suppose here I take point A, and suppose here I take a point B, then AB is a line segment and it has a definite length, right? And this directed line segment, this has direction as shown here, and this directed line segment is written like this, and it is known as a vector, right? So this is known as a vector. Now similarly, if we take suppose this is line L1 and here we have L2, and say here we take C and here we take T, then the direction of this line segment is shown here, and this is again a vector, right? So a quantity that has magnitude as well as direction is called a vector, and a directed line segment is a vector, and it is denoted as here in this case it is denoted as vector AB, and it is read as vector AB, and in this case it is written like this and read as vector CD, right? We can also write this vector AB as vector A, right? So we can write here as vector A, here we can write vector B, and this can be written as vector B. Now the length of this vector AB is denoted by this sign, that is the magnitude of vector AB is written like this, or we write it like this, and similarly in this case the magnitude of this vector CD is written like this. Clear? Vector B. So this symbol represents the magnitude of vector A, and this symbol represents the magnitude of vector B. Sometimes we simply write as A or simply write as B. So this symbol sometimes represents the magnitude of this directed line segment vector AB, right? Now let us take this vector, and I am again drawing it like this. Suppose let us take this vector CD. So here we have C and here we have D, and C, the direction of this vector is shown here, and if we denote it like this, then we have the vector CD. Clear? Now here the vector CD, this starts from this point C and it ends at this point D. So this point C is called the starting point or the initial point, and this point D is known as the terminal point, right? This is called the terminal point. So for example, if we take a vector, suppose this is a vector C, and suppose this is O and this is P, then O is known as the initial point. This is called the initial point, and this is called the terminal point, right? Now let us take the types of vectors. So in vector algebra, we come across with different types of vectors. So the first one is zero vector. So a vector whose initial and terminal points coincides is called a zero vector, or sometimes it is called the null vector, right? And it is denoted as 0, and if we take or we write a sign of arrow over this 0, right? So what is a zero vector? A vector whose initial and terminal points coincide is called a zero vector or null vector, and it is denoted by this symbol. And the zero vector, it cannot be assigned a definite direction because its magnitude is 0, right? So the magnitude of zero vector is 0, right? So the vector, for example, the vector PP or the vector QQ are known as the zero vectors. Why? Because suppose we have a vector such that here we have say P, and here we have Q, and this is a vector PQ, and P is the initial point, Q is the terminal point. But when Q and P coincides, right? So when Q and P coincides, then the vector PP becomes the zero vector, and similarly vector QQ becomes the zero vector. So therefore we can write this vector PP as vector 0. Similarly here we can write 0 vector. Clear? So the zero vector cannot be assigned a definite direction. It means its direction is indeterminate. The direction is indeterminate. That is, zero vector is not unique. Zero vector is not unique. Okay. Now come to the concept of unit vector. So a vector whose magnitude is unity, that is one unit. That is one unit is called a unit vector, and the unit vector in the direction of a given vector A is denoted by A cap, right? So suppose we have a vector, say this is O point and this is point A, and if this vector is denoted by vector A, and this vector A is said to be a unit vector if the magnitude of vector OA, that is vector A, is 1, then this vector A is known as the unit vector, and instead of writing it as this, we can write it as A cap, right? So the magnitude of A cap is 1. Okay. Now suppose this is a vector OB and this is vector B. Now let the magnitude of vector OB is, say, 5 units, right? So what is a unit vector in the direction of vector B? So let us take here, if we take a point C here, such that vector OC is denoted by vector B cap, and the magnitude of vector B cap is 1, then this vector B cap is known as a unit vector in the direction of vector B, right? And the magnitude of vector B cap is 1, and here we have also an important result, that is B cap can be written as vector B divided by the magnitude of vector B, right? Or we can write it as vector B can be written as the magnitude of vector B, and here we write B cap. Now let us take co-initial vectors. So what are co-initial vectors? Two or more vectors having the same initial point are called co-initial vectors. For example, suppose we have here say 3 vectors. Suppose this is O, this is vector A, this is vector B, and this is vector C. Now suppose here we have A, here we have B, here we have C. Now here we see that in all the vectors OA, OB, and OC, we see that O is the common initial point, right? So the initial point of all these 3 vectors, that is vector A, vector B, and vector C, are same. Hence these 3 vectors OA, OB, and OC are known as co-initial vectors. Now come to collinear vectors. So 2 or more vectors are said to be collinear if they are parallel at the to the same line, irrespective of their magnitudes and directions, right? Or in other words, we can say that vectors having the same or parallel supports are known as collinear vectors. For example, suppose here we take suppose here we have A, here we have B, and here we have C, and the direction is as shown here, and in this figure we see that vector AB, BC and vector AC, and all these three vectors are collinear vectors, right? So two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and direction. Now come to the concept of equal vectors. So what are equal vectors? Two vectors A and B are said to be equal if they have same magnitude, right? That is, the magnitude of vector A is equal to magnitude of vector B, and the second thing is they have same or parallel supports. It means suppose the two vectors are taken from the same parallel line, right? It means the parallel supports. And the third one is the same sense, that is, both the vectors should have the same direction. Then the two vectors are said to be equal vectors, or in other words we can say that two vectors A and B are said to be equal if they have the same magnitude and direction regardless of the positions of their initial points, and it is written as vector A is equal to vector B. Now here let us take these two figures. So viewers, here we have two vectors. Here we have vector AB, and let us call this vector as vector A, and here the vector CD, right? Now these two vectors are said to be equal, that is vector A is equal to vector B, if they have same magnitude. So if the length of vector A is equal to the length of vector CD. So the first condition is satisfied, and the second is same or parallel supports. So here these two vectors are having the parallel supports, right? And the third thing is having the same sense, that is the direction. And here we see that from this figure these two vectors are parallel and they have the same direction. So the two vectors are equal. Now let us consider the second figure. Now here we have the two vectors, vector AB, and here we have suppose vector AB is vector A, and here we have vector BC, right? So let us say this is vector B. Now if the length of vector AB is equal to the length of vector BC, and since the direction are same and the magnitudes of vector A and vector B are same, and they have the same or parallel supports. So here this line, right, this line L, and these two vectors are lying on this line L. So therefore these two vectors are said to be equal. Now here I would like to mention the meaning of support, and the support word has the meaning here. See this figure. Now here the support of vector AB is the line L, of which vector AB is a part, right? The support of vector AB, the support of vector AB is the line L, of which vector AB is a part. Similarly, the support of vector BC is also the line L, right? So here the same or parallel supports means the vector AB and vector BC, or we can say vector AC, has the same support as line L, right? And here in this case, see this vector AB is a part of some line, right? Suppose this is the line L1, and this vector CD is also a part of some line L2, right? And here the support of vector AB, in this figure the support of vector AB is line L1, and here the support of vector CD is line L2, and line L1 is parallel to line L2. So this is the meaning of the point number 2, right? Same or parallel supports. So here the two vectors have parallel supports, and in this figure the two vectors, vector A and vector B, which are equal, have the same support. Now come to the negative of a vector or negative vector. So a vector whose magnitude is same as that of a given vector, say AB. Suppose here we have a vector AB, right? And a vector whose magnitude is same as that of a given vector AB, but direction is opposite to that of it, is called negative of the given vector. So for example, here if we write vector AB, so vector AB is equal to minus of vector BA, right? But the magnitudes of both the vectors, that is vector AB, is equal to the magnitude of vector BA, but the directions are opposite, and the opposite direction is shown here by this negative sign, right? So for example, if we denote this vector AB by vector A, then vector AB can be written as vector A, and vector BA, whose direction is from B to A, is written as minus of vector A, right? Now here consider this figure. So here we see that if OP is equal to OQ, right? Or if the magnitude of vector OP is equal to magnitude of vector OQ, then here the vector OP is equal to minus of vector OQ, right? Because vector OP and vector OQ has opposite directions. Now come to the concept of like vectors and unlike vectors. So what are like vectors? So vectors having the same direction, vectors having the same directions are known as same direction are known as like vectors. And what are unlike vectors? So collinear vectors having opposite directions are called as unlike vectors. So like vectors are vectors having the same direction, and unlike vectors, collinear vectors having opposite directions are known as unlike vectors. Now come to the concept of free vectors. So what are free vectors? If the initial point of a vector is not specified, it is said to be a free vector. For example, suppose we have a vector, say this is O, this is A point, and here the initial point is O, and here the final point is, or the terminal point is point A. Now if we know the initial point of a vector, then the vector is not a free vector. But if the initial point of a vector is not specified, it is said to be a free vector. Now here let us take an example. So here we have given a figure, and here we see some vectors, and we have to tell which vectors are co-initial vectors. So what are co-initial vectors? So vectors having the same initial point are known as co-initial vectors. So here we see that vector A and vector D, this is the same initial point of these two vectors. So vector A and vector D are the co-initial vectors. Now what are the equal vectors here? So what are equal vectors? So equal vectors are those vectors which have the same magnitude, the same or parallel supports, or the same direction. So here we see that vector D and vector B, vector D and vector B are, these two vectors are equal vectors because they have the same direction and they have the same magnitude and they have parallel supports, right? Now what are the collinear but not equal vectors? So here we see that vector A and vector C are collinear. Vector A and vector C are collinear, but they are not equal, right? Why they are not equal? Collinear but not equal. Why? Because they have the opposite direction. Vector A is in this direction and vector C is in this direction. So they are collinear because they are parallel, right? But they are not equal. Now let us consider the concept of multiplication of a vector by a scalar. Now let A be a given vector and lambda a scalar. Then the product of the vector and the scalar lambda is denoted by lambda times vector A, and lambda times vector A is collinear to vector A. Now here we have a vector A, and if the value of lambda is 2, then see the vector 2 times of vector A is shown here, and obviously the length of this vector is 2 times the length of the vector A, right? So here lambda is equal to 2. Now here we have taken lambda is equal to half, so the length of this vector becomes half the length of this vector, but the direction remains the same, right? And here see lambda is equal to minus half, and the length of this vector becomes half the length of this vector, but the direction becomes opposite to the direction of this vector, right? So the direction of the vector lambda times vector A depends on the sign of the scalar lambda, right? So if lambda is positive, then the direction of lambda times vector A is same as vector A, but if lambda is negative, then the direction of this vector lambda times A vector is opposite to the direction of vector A. And if lambda is 0, then lambda times vector A becomes 0 times vector A, and this is equal to 0 vector, right? So in that case lambda A vector is equal to 0 vector when lambda is equal to 0, right? Now the magnitude of this vector, that is lambda times vector A, is denoted by this symbol, and we can write it as the absolute value of lambda times vector magnitude of vector A, right, equal to the magnitude of lambda and the magnitude of vector A, right? Now here if lambda is say minus 1, then lambda times vector A becomes minus 1 times vector A, and that is equal to minus vector A, right? So here we see that when lambda is equal to minus 1, then lambda times vector A is equal to minus of vector A. And here the direction of this vector is opposite to the direction of this vector. So minus A vector is like this, right? The direction of this vector, negative of vector A, is in this direction, but the magnitude of this vector and vector A are same, right? So they are opposite vectors. So vector A and minus vector A are opposite vectors, right? Okay. Now this vector minus A vector is known as the additive inverse of vector A, right? And we write vector A plus minus vector A is equal to 0 vector, right? So the sum of a vector and its negative is always equal to the 0 vector. Now if lambda is equal to 1 divided by the magnitude of vector A, provided vector A is not equal to the 0 vector, then if we substitute this value of lambda here, we see that the magnitude of lambda A vector is equal to 1 divided by magnitude of vector A. Here we have magnitude of vector A. Both these quantity get cancelled and we have 1. So this expression, that is the magnitude of lambda times vector A is equal to 1, and this shows that lambda times vector A is a unit vector. It is a unit vector, and the direction of this vector is in the direction of vector A, right? And the unit vector which is in the direction of vector A is denoted by A cap, and A cap is written as 1 divided by the magnitude of vector A times vector A, right? Now viewers, here there is one important thing, that for any scalar, k, we have k times of 0 vector is always equal to 0 vector, right? Now let us consider the concept of additive identity. Now for any vector, vector A, we know that the sum of vector A and 0 vector, or the sum of 0 vector and vector A, is always equal to vector A. So 0 vector is known as the additive identity of vector addition, right? Vector addition. And what is the additive inverse for the vector A? The additive inverse of vector A is minus of, or the negative of vector A, and this gives us vector 0, right?